Should the camera be on or off for the webinar?
That's pretty much up to you. My camera, like after I've done the introduction, I will turn my camera off and basically hand over the reins to you. And then you said you would like the questions at the end. So basically, once you finish doing the talk, then I will like bring the camera back up and say thank you.
Yes.
And like say, well, there's some questions. Maybe you want to get started with those.
Yes.
And then at the latest, probably 5 past 10, 10 past 10 at the absolute latest, then I will have to scoot off to get ready for the next talk.
Yeah. So I will switch on the camera for the intro and then off for the talk to save bandwidth. And for the Q&A, we'll put it back on, basically, if necessary.
Yeah, that
if there are any questions.
A lot of sense. Yeah.
Cool. So we are close.
So just so it doesn't catch you by surprise, we've got 35 seconds.
Okay. The stream starts automatically.
Yeah.
Okay. Just closing my door in that case, just to avoid any disturbances. We are good. All good.
Okay. Then 15 seconds. So, good morning and welcome to the first session of DevOpsCon Online Edition 2020. Hope you all enjoyed the keynote just now. And right here, you can see in the window next to mine, we've got Johan Le Chevalier. He works at Lightstep as a solution engineer based in London, and he's going to be giving us a talk on distributed tracing to observability. So, Johan, I think I'll just give the floor to you straight off.
Thank you very much, and good morning, everybody. I'm very excited to welcome you today to this webinar, which aims to speak about observability and precisely what we do at Lightstep to address that. So this presentation is going to last more or less 45 minutes, and we have a bit of time at the end for questions, so feel free to ask any questions. And at the same time, as we are going to stay open all the day for any following questions, we can chat later after this talk in the virtual booth. And don't forget as well to register for the raffle. There is a link in the public chat where you can register to win a drone, basically. So I'm going to switch off my camera now. I will put it back at the end of the talk for the Q&A, just to spare some bandwidth, because as we all work from home, we have to manage that as well. So welcome again to this complete guide to observability. So my name is Johan Le Chevalier. I'm a solution engineer working for Lightstep, based in London. And I'm glad to present you today our approach to observability at Lightstep. So Lightstep basically is a startup based in San Francisco, which aims to develop a product, an opinionated platform that brings up simple observability for deep system and help you to understand the complexity into your distributed software architecture regarding monitoring, performance, troubleshooting, regression, and having alerts that means important information compared to noise that could be triggered by traditional tools. We will cover that in a few moments. So basically, what I would like to touch on for today, and what I would like you to walk away from this webinar, is to understand what is observability and how deep systems are impacted by observability, why you need observability for your complex software architecture, and how we can help you with Lightstep. So first thing first, what is observability? The term sounds like obvious, but in terms of definition, the observability term has been introduced in the past in the control theory. And initially speaking, it was addressing complex systems such as plants, manufacturing plants like chemicals factories, where site reliability engineers, they had to understand the very complex internal systems by observing external factors, external outputs, and inferring the internal state of complex systems. So obviously, we are not chemical engineers. So what does that really mean now those days for the software industry? Basically, it's the capacity to understand an effect and to from an effect to get the cause of the effect. So as an example, if you would like to understand from a spike of errors that you have an identify a misconfiguration in your software, in a component, or for example, if you detect an increase of latency on your database, it's because you have some customers or users, they are making some crazy queries on all the tables. Or for example, if you have users complaining about the performance of the checkout operation on the iOS app, it is because basically in your backend environment, you have updated a component that is just introducing major regressions and slowing down the user experience. So observability would, in that circumstances, would be the ability to navigate from the effect, those errors, spike, increased latency, or complaints, to identify the cause of that and to solve it. And it's not the other way around, where basically you know the cause and then you find the effect, because it would certainly mean that if you can find the cause, you would fix it and you would not have the bad effect. So that's, in a sense, what observability is. And for the software industry, it's very really answering the question of what's going on my system. I have been deploying a new version of my component, and it's performing differently. We detect some regressions, a peak of latency or a peak of errors. What's happening on my system? Or maybe we see some end users having problems, and where is the cause of this problem? Is it on my service, or it's connected to something related to it? Observability would certainly be able to answer to that question. So now it's slightly more clear what observability is. You may probably have already heard about the 3 pillars of observability, which are metrics, logs, and traces. And all of them are great sources of data which are meant to help you to bring a visibility, a complete understanding of what's going on. So metrics are very common, and we are all familiar with metrics. And a metric dashboard looks certainly like something like that. It's nice. It's different key values. So it can be a sensor, it can be a CPU usage, it can be a memory usage, or whatever usage plotted against the time. And you see a time series approach. It's a value against the time, as an example, and you can make some very complex mathematical computing on them, average, regression, and things like that. And that's really the concept of metrics. The problem with the metrics is that as you grow your system in complexity, I mean by adding more independent services or distributed your system, like in modern software architecture with containers, serverless functions, or even if you start to break down your monolith application into a lot of different components which are running on different hosts, on different virtual machines, or even different places, different data centers, different cloud providers, the number of dimensions for those metrics are going to increase. And as an example, if you look at this curve and you see, let's imagine this curve represents a CPU usage consumption. You see that there is a peak after 12, and this peak is for a certain period of time. It's a kind of plateau. So you understand that, oh, something is wrong on my system. I have a peak of CPU usage. Great, but where is the problem? What is the problem exactly? So at this point, this metric doesn't really answer the question. So you need still another step. You need to break down this metric and potentially group it by another dimension, such as the container name, the container ID, or the host name, and things like that, so that you can identify where the problem happens, basically. And once you get that, you still don't know what is the cause of the problem. You know where the problem is happening, so you have identified one of the dimension where the problem is happening, and that's fantastic. It's a good start, but still you need to go then on this specific host or go through the logs related to this specific host to find out what is the issue. So with the metrics, one of the major issue is that the cardinality is not unlimited. And somehow, the metrics solution providers, they will charge you on the cardinality. So you may start thinking about the price you would pay for using a solution with metrics with unlimited cardinality, and as you may need more cardinality due to your distributed application, and then the bill is going to rise at significant levels. And you can just look around on the market. Software based on cardinality, custom metrics, for example, are very expensive. So that's a real problem for this specific pillar of observability. The cardinality comes with some restrictions, and it's not necessarily fair to have to pay so much to be able to have unlimited cardinality. So the second pillar of observability is related to loggings, and logs have been here forever. I would say they are very familiar. You just log information and it's basically statements from your applications. They can be structured or unstructured, and you can consolidate them into a central place, and from that go through them and extract some value and understand applications issues from them, and it's really commonly used. The only problem with logs is that it's working really well when you have a few systems and where you have monolith applications, as an example, where they produce logs into specific places where they can be reached over the network, as an example. But as you go through the migration from your monolith into a distributed architecture, software architecture, where basically your components, they can be numerous, the number of logs which are going to be created are going to increase. So as an example, if you keep the same transaction rate as with a monolith, but you break down your monolith into a lot of different boxes, as you can see on this diagram, the number of logs are going to increase by the number of microservices times the cost, basically, to transfer those logs over the network into a central storage place, times the cost to keep them over weeks or months or years. And the cost of your logging solution is going to increase dramatically, and it's not going to be in the same relationship as basically your business. So the problem with the logging solution is that as soon as you start to embrace distributed architecture, they are going to cost you much more than you can really afford for it. And that's going to be their weakness, basically, with regards to observability in modern software architecture. And last but not least, let's talk about tracing and traces. So here, this screenshot is an example of a trace from a Zipkin UI. And the trace basically represents all the steps taken across distributed components where they share a common baseline, and you can very simply identify service per service where you are spending time, where there is a critical path, or where there are some errors, basically. So it's really powerful to visualize across distributed services what's going on. The only problem with traces is that, again, as you have a lot of different components, or your transaction is very huge, the amount of traces can be generated in a very large amount, and you may be tempted to sample. And the sampling strategy you will adopt will be to reduce the cost or to adjust the performance so that you can manage the amount of traces, manage the amount of events you drop from those you keep. And those strategies will rely on sampling strategy, head sampling or tail sampling, and none of them may be the best approach to provide observability. So as an example, if you go with a head sampling strategy, you will randomly define at the client level if you keep or you discard the trace, regardless of the outcome of the trace itself. So you may have a transaction that starts and have some errors in the backend services. If you decide at the client level when it starts that you are going to discard this trace, you are going to lose all the backend events and potentially those having problems and latency and errors, which may be interesting for you to investigate. So head sampling is great to reduce the amount of traces generated, but at some point you may miss very important outliers in your system. And it's the same for tail sampling. Tail sampling is a strategy where you observe everything and in a central place, and you decide from what you observe what you can discard from what you can keep. But to be able to achieve a tail sampling, it requires a central visibility and a central approach, which can be very complex to build. So none of those approaches are really working in the actual world without heavy compromises on outliers detection or representatibility of the data. So in essence, there are three pillars to provide observability: logs, metrics, and distributed traces. However, they all come with some flaws and fatal flaws, making a solution very difficult to bring forward. So, before seeing how Lightstep can help you to address that, let's pause and reflect upon how we have been able to get there. What are the main causes which are explaining this situation? So, in a sense, it's scalability, the scale of everything, the scale of the transaction, the scale of the systems, and that's one of the main reasons why we are here. And when we speak of scale, there are two ways to scale a system. The first one is to start small and to increase with the same thing. So you start on a small pond, a small amount of water, and by increasing the water, you get a very big lake or even an ocean. So it's what we call scaling wide. You just add more of the same thing and you get something bigger. And this approach has already been solved from a computing point of view, from a software point of view. It's MapReduce-like approach where you divide and conquer with the same elements. But it's not necessarily a very difficult problem to solve from a computing point of view, from a software point of view. But the other way to scale is to scale like a village. You start small and then it's evolving into something much more complex. And it's scaling what we say scaling deep. It means the structure of the village changes and the shape of the city is totally different from what it was originally on a village. And because of that, if you want to move from one place to the other, in a small village, it's very simple. You need to cross the street and go to your neighbor to speak to him. But in a big city, it's much more difficult. If you want to speak to someone on somewhere else in the city, you may use different ways or tools to get there. You may use a cab, you may use Google Map, because the shape of the city is not linear. It's not only bigger, but it's more complex in terms of structure, not only horizontally, but vertically as well. So when we say scaling, it's about that scale dimension. It's scaling deeper, meaning the systems, they are more complex relationship altogether. And from a software point of view, what it means is something like that on this diagram. You may have a software that is made of different components. They may be hosted in different places, such as public clouds, private clouds, or different data centers, and they may be exposed to different services, private or public. You may use or integrate third-party APIs, and all of that is going to make your software solution. So as an example, if you have an application running on iOS, this application can be connecting a backend service on Amazon after using an STO service mesh, which is going itself to this backend Amazon service, connecting to other components in other languages on other cloud provider potentially, and so on and so on. And that's going to make your complex software architecture. And it's not necessarily complex in number, but as you see, complex in terms of relationship. It's deeper, and that's what we call a deep system. And basically, if you are owning one of those components, such as the Java services, yourself, your team, or even your company, when something goes wrong on your system, it may impact upstream, the different components, up to the service exposed to the users, or it can impact downstream other services in your environment, in your company. And all of that basically is going to be the range of action, the range of interaction of your service with the other components. So because your system is deep, the level of impact of the problems on each of those dots on this diagram, each of those services, can be much more deep and wide than it was in the past when we were used to develop system in an isolated mode, basically. Now, because everything is connected, the impact is going to be much, much wider. So that was we call a deep system, and that is how basically the situation is today, meaning that using traditional tools such as dashboards by monitoring specific services, or using logs, or using traces, individual traces, is not going to fit for purpose to bring this complete observability and understand when something goes wrong in one place, the level of impact it can have upstream and downstream on all the different components. And that's a real challenge of deep system, and that's a real challenge of observability those days, is that the traditional tools we have, they are not providing us enough details for observing the performance, the errors, or the regressions on our new software architectures, basically. So the cost of using traditional tools, metrics, logs, and local traces or sample traces can be various, and you may already be experiencing it, basically. So you probably spend more time on call, try to figure out a problem, trying to solving an issue, and what it means basically that because you spend more time to solve the issue, it impacts your business, and the level of impact on your business is much important. So it can slow down at some point the development of new features, because every time something is developed or pushed or innovated on your services, it triggers a lot of pushback from the testers for Q&A before to get into production. So because of that, you start to get some kind of fatigue or apathy from your developers, because they are frustrated not to be able to cope with a pace of and speed of development. But also, traditional tools also may rely on tribal knowledge. Few people, they know exactly what's going on, and as the team is moving and people this knowledge can disappear. And because as well, since you may spend more time to solve the issues, it may start to impact your business. It may start to damage the brand, your brand, the visibility, and as well your reputation, and obviously drive some cost and impact your revenue. So you may witness loss of revenue because of those outages and the time spent to solve them. So we all agree on that. The traditional tools are not fitted for modern software architecture, and we must find a way to solve that. So what Lightstep can help you with, and how we can help, and what is observability in action. So at Lightstep, we think that you need observability across your specific services and dependencies, but not only yours, but as well as a team, as a company. You must be able to understand very quickly what's happening and what is impacted by performance regression, latency, or errors, so that you can very quickly identify hotspots and issues before they impact business, before they start to produce some damage on your brand. So for Lightstep, the right observability solution is a product that is opinionated, which is coming out of the box with all the features you need based on telemetry data, which are basically information sent by your applications, monitoring information sent by your application, and using distributed traces to collect the context of what is important, and from the distributed traces correlate with logs and the metrics, so that you get the context of the information which is relevant, and you can see very quickly regressions on the platform, and without sampling between the application and the collection layer, so that you never miss any outlier. And this solution is going to provide you immediate access to performance issues, regressions, and errors, and enable your developers to be agile, to push and develop new features across your distributed services with confidence. And that's how we see a right observability solution at Lightstep. So we are super proud to announce that Lightstep is a right product for that. It brings observability with context. And how we do that is basically relying on analyzing 100% of the monitoring information at scale sent by your applications, regardless of where they are, and regardless on how they are running on monoliths, microservices, serverless functions, in cloud, public cloud, private, multiple cloud. It doesn't matter for us. We can collect 100% of those monitoring informations at scale, and then create aggregates and provide you trace analysis capabilities across distributed components, and provide you as well out of the box automatic deployment regressions and latency regressions and error regressions detection, as well as real-time query capabilities for the necessity of troubleshooting real-time performance problems or error problems, and have providing a platform as well that brings alerting with context, so that you don't spend hours in filtering and in triaging. With this approach, you just have the signal straight away out of the noise made by the traditional conventional tools, and that helps you to very quickly identify the root cause of an issue, so that you can fix it very quickly and get back to the normal very quickly as well, before it impacts your business, before it impacts your reputation. And the approach of Lightstep is based on open source standards as well, so that you are not locked in with a specific vendor. So that's how we define observability with context as Lightstep, and how we do it basically. What is required to achieve that in terms of architecture. So at the very beginning, you need your applications, obviously, instrumented applications with open source standards such as Open Telemetry, Open Census, or Open Tracing. Those applications can be of different natures, and you can mix and match. It really doesn't matter for us. It can be microservices, it can be serverless functions, or legacy monolith applications, or even logging system sending logs to the collection layer, or already instrumented applications with Jaeger or Zipkin. And it can be as well mobile, front-end application, web applications. It doesn't matter for Lightstep. So those applications will send monitoring information to Lightstep. There will be no head sampling between the applications and the collection layer. And basically, the collection layer is, as illustrated in green on this diagram, is called satellites. They are designed to scale up horizontally as bare metal servers, containers, or virtual machines in data center, private cloud, public cloud, or a mix of all of that. It doesn't matter. They are designed to be stateless components to capture 100% of the monitoring information sent by your applications. And they will connect back to the Lightstep SaaS in a secure way, and create aggregates and analysis to connect back a very small percent of what is collected initially between your applications and the satellites. So there is no head sampling between the application and the satellites, but we do a dynamic tail sampling based on all the information we have been able to capture, so that you never miss any outlier, you never miss any rare event or very specific errors that very rarely happens, this approach permits to get this level of fidelity, and is very efficient from a performance point of view, and as well from a deployment and a scalability point of view. And the last part of the architecture is the SaaS platform, which is going to bring you all the use cases out of the box. So it means that you are not going to spend time building very complex dashboards, building very complex software relationship, so that you can visualize things, visualize distributed traces, visualize service diagram, or have a dashboard with regression detection on latency or errors. All of that will come out of the box for you, and will be maintained. It will be secured. It will be highly scalable, and we are going to provide constant innovation in the features on this platform. So you don't have to worry about maintaining yourself a very complex distributed solution for your observability solution that will be done for you by Lightstep in the SaaS, basically. So based on that, our approach is really super unique on the market. And we have a lot of different customers adopting the solution, and in a lot of different ways. So as an example played, they are using Lightstep in their CI/CD environment, and they were lacking. They were having a lot of problems because of lacking visibility into their microservices architecture. They had to manually find errors between the different components, and the cost associated to their solution in terms of storage and people spent trying to fix the in-house observability solution was really expensive. So when they adopted Lightstep, they were able to reduce their MTTR, or the time to identify the root cause of issues, by 20 times. They were removing the need to have specific engineers dedicated to build an in-house observability platform, and they could reallocate those budgets, basically, to spend more time in building new features for their product, so that they can stay ahead on the market, they can still innovate and be the best in what they do. So that's how Lightstep helped them in terms of observability, and how this observability approach helps them to be more performant in their environment, in their market, and innovate. And the money they were able to relocate to develop new features. Another example with Lyft, where Lightstep helped them to migrate from monolith application to microservices. The architecture used by Lyft was really complex, and they had more than 200 services running across different environments, and they wanted to be able to observe 100% of their application performance, because as a platform exposed to customers' interaction, their business was really easily impacted by latency or regressions. So to be able to increase the performance on the application, to remove the friction, and to avoid losing customers by providing a better user experience, they had to find a way. They had to find a solution to help them to identify quickly the root cause of their issues in terms of performance or errors, to connect the dots between all the different components, from the mobile front end, from the mobile application exposed to the user, to the backend services running in their data center. So they moved and they adopted Lightstep, and by using that, they were able to improve the efficiency of their application by 60%. They were as well able to reduce the root cause analysis time by 60%, and then improve the post-mortem process to understand when they have a problem, so that they can improve the quality of their software, and obviously being able to improve the user experience and retain their customer, avoiding them to go to the competition, as an example. Next, Lightstep can as well be used to optimize performance across your distributed software. And as an example, InVision used Lightstep for this purpose. They were using distributed traces to identify the critical path of transaction, but not in a efficient way. They wanted to observe 100% of the performance application across their entire distributed system. But at the same time, they were not able to get a macro view of the interaction across services and the clients in the new and legacy services. And they were not able to pinpoint the root cause of the performance issues they had when they happened across different service boundaries. And they were not able to achieve that with their legacy APM solution. So by adopting Lightstep, distributed tracing and Lightstep and the observability solution provided by Lightstep, they were able to improve their performance by 75%, reduce the time to identify the root cause of their problem and to solve them as well, and ensure end-to-end performance management across all the distributed services, being able to connect all the dots, and as well, because of that, lower the cost compared to their previous APM, and improve their developer productivity, so that they were able to more confidently push innovation and add new feature to the product. And last but not least, SendGrid was able to improve their customer experience with Lightstep, and they were able to improve the time to reduce the issue by 92%, and the time spent initially by trying to solve problems was saved by a number of really important number of hours, and they were able to invest the time into engineering to the new features up to 20 hours per week, and to launch new feature in their product thanks to Lightstep. So really, Lightstep can really help you in a lot of different ways with its platform, bringing observability across different components, such as those we have explained. We could come back into the public chat in the booth on more use cases. We would be more than happy to do that and to chat with you today, as we are going to stay open till the end of the event. And if you would like to practice observability, if you would like to test Lightstep, you can access to the sandbox on lightstep.com/sandbox. It's free, and you can use it and follow some tutorials that would help you to understand how Lightstep can help you to find performance issues, detect regressions when you deploy new features, and have a complete observability on your services with an opinionated platform coming with all features out of the box. So I'm going to stop there and to pause now and give you some time back, and potentially take your questions if there are any into the chat room, and yeah, we can carry on from there. So are there any questions? I think you're on mute.
I see. I was muted.
Yes, you are on mute. Sorry for that.
Fortunately.
Yes, I can hear you now.
So yeah, I was just saying thank you very much. That was a really interesting talk. And at the conference right now, you know, we'd have a bunch of attendees who we could see and hear who might be applauding for you. So since we can't see and hear you, if you want to show your appreciation in the chat, then that would be really nice. And then, yeah, if you've got any questions, please feel free to submit them right now, and Johan will answer them. Yeah. You said the room's going to be open all day, right, Johan?
Yes, totally. We are going to stay here all day. So if you have any further questions, you can come back and visit us and ask in the chat if necessary. We'll be here to help answer the questions. And don't forget to register for the raffle and to leave your name so that you can participate to the cast to win a drone as well. We have shared the link for the Google form in the public chat. So feel free to register to participate to the raffle.
Okay, then it looks to me like we don't have any questions that are very pressing right now.
Okay.
So in that case, I'd like to say thank you once again, Johan. Thanks also to our attendees for coming to watch. And I'm going to head over now and start prepping for the next session. So that's it from me here. If I don't see any of you again today, then I wish you a great rest of the conference. Otherwise, I'll see you later.
Thank you very much, everybody. Have a nice day.
Thank you.
Bye.
Bye.